Hello everybody, welcome or welcome back to my channel. In today's series of 10 minutes, today's video of 10 minute series, we'll be learning AC signal applied to pure resistor circuit. So in this, there's actually, today we're doing resistor circuit, but totally we'll have to learn 6. So we will be getting 6 videos of this AC signal applied to circuits. So one is pure resistor, pure inductor, pure capacitor, then you'll have RL, RC, and finally RLC. So these 6 we'll have to learn individually, each of them. This is quite challenging because each of them have different derivation sort of thing, waveforms. So I'll be making you understand and basically learning also, not just understand. Learning is also very quite important by heart and remembering things. So all that we'll be doing. So first, let me start with AC signal applied to pure resistor circuit. So let's start off with the diagram, circuit diagram. So this is S a symbol and this is AC, correct? So V equals Vm sine omega t. This is resistor and this is current flowing. Denoted with small I, okay, and capital R. So we know that V equals to IR by Ohm's law. We have to find I, okay? We know Vm sine omega t equals IR. I is what? Vm sine omega t by R. So I equals Vm by R, we can write as Im sine omega t. We can see, and V is also what? Vm sine omega t. Is there any phase difference in both of them? No. So both of them do not have any phase difference. They're in the same phase, right? The phase difference between voltage and current is 0 for pure resistance. This is for pure resistance. So the current is in phase with the voltage for pure resistance. Current is in phase with the voltage in pure resistance. So now we have learned current circuit diagram and VI equation we have got. Now let's do the phasor diagram. There's no phase difference. So V is also in here, I is also here. There's no phase difference. This I did know with capital letter. There's no phase difference. Now let's draw the waveform. Voltage, current and power waveform. So first always start by drawing the, first let's try to write the voltage waveform. Only one cycle is enough. 0, pi, 2 pi. When we learn RL, LC and RLC, it's going to be a little confusing. So just try to make your own tricks to remember how you're going to remember it. For this 0, pi, 2 pi, only these 3 are required. This is the voltage. Now current will always be lesser than voltage. I have to remember. It's same phase. It is in phase with voltage but lesser in magnitude. So how are we going to show that? Something like this, okay? Then this is voltage, this is current. Now while drawing power, look at this. Both power equals to VI, we know that, right? So voltage and current both are in positive half cycles. Power will also be in positive half cycle. So there's some glitch. Just give it some time. It'll readjust. Yeah. Here negative, also positive. This is okay. Let's this is VIP. This is omega t. This is power. Always try to shade the power. I hope you understood why it's in positive cycle. Negative and negative also positive. Positive also positive. And then you can draw one line like this. Make this as P average. That's it. P average equals VI. Now that also I'll tell you how this P average equals to VI. Okay. Current is following voltage in same phase but lesser magnitude. That's it. Now let's try to derive instantaneous power. Instantaneous power. We know that power equals V into I. V also we found out Vm sine omega t. I also we know Im sine omega t. So Vm Im sine square omega t. Now formula time. Sine square theta equals 1 minus cos 2 theta by 2. You have to remember this. Sine square theta is 1 minus cos 2 theta by 2. Sine square theta is 1 minus cos 2 theta by 2. So what will we get here? Vm into Im 1 minus cos 2 omega t by 2. Now let's multiply Vm this whole by 2, right? So Vm Im by 2 minus Vm Im cos 2 omega t by 2. This is the power equation. Final power equation is this only. Now whichever has cos omega t, sin omega t, that is known as the pulsating term, and this is the constant term. What you have to remember is that the average of the pulsating term over a cycle is always 0. So this becomes 0. This becomes 0. So P equals to Vm Im by 2. If this is P average, now this P average is P average equals to Vm Im by 2. This can also be this. Now small p written as P average. So I hope you have understood. This is equals to Vm Im by root 2 into root 2. So P average equals to Vrms into IRMS. Vrms into IRMS. So it's basically P equals to Vi. Basically watts, where I and R are in RMS values. So that's it. We have finished one set of this where we learned the circuit diagram, V and I equation, phasor diagram, waveform and instantaneous power. And trust me, these topics can be learned only by repeated revision, repeated practice. It cannot be learned. So I'll try. Now I have also learned with you guys only. It's not like before I have practiced 10 times and I'm doing the 11th time here. No. Even while teaching, when I'm solving, I saw the book only and did. So now I want to test myself. So now I'm writing the entire thing without seeing. I want you also to do something like this for yourself. You can pause the video or end the video and come back and check whatever works for you. What or not are we supposed to cover? Let me write that also. Circuit diagram. This is specifically for R. For RLC might vary. I'm talking about R here. In this video about R I'm concentrating. So to circuit diagram, V and I equation. Okay, V and I equation. Then we had instantaneous power equation, waveform equation, waveform not equation, waveform, then phasor diagram. That's the things which we covered, right? So these things I have to cover now. So let me begin. Just have a circuit diagram. This is for AC signal is applied to pure resistor. So pure resistor is there. Here AC current is flowing. This is R. This is V equals Vm sine omega t. Then we know that V equals to IR. So Vm sine omega t equals I into R. I we have to find out Vm sine omega t by R. So I equals to Im sine omega t and V equals to Vm sine omega t. The current there's no phase difference. Current is in phase with voltage. In phase. If there's no phase difference, what do if there's no phase difference, what do we say? Current is in phase with voltage for pure resistor. Now coming to the phasor diagram. Just now we saw phasor diagram that there's no phase, so Vi. Let me first derive the power equation, instantaneous power, then I'll draw the waveform, so then it'll make more sense. We know that power equals to V into I. So that is equals to Vm sine omega t into Im sine omega t. That is equals to Vm Im sine square omega t. Sine square theta formula is what? 1 minus cos 2 theta by 2. Maybe just now we did, that's why I remember. Maybe after 5 more days I might not remember. So what should we do? Just revise. That is equals to Vm Im 1 minus cos 2 omega t by 2. That is equals to Vm. Don't forget about bracket. If you forget about bracket, then the problem starts. Vm Im, because here it was single term. Here it is more than one term. So bracket is required. Vm Im by 2 minus Vm Im cos 2 omega t by 2. So I told you whichever has cos omega t or sin omega t or such kind of terms, that will be called as the pulsating term. This is the constant term, right? P all along. So we know that the average of the pulsating term over a cycle is 0. So P average equals to Vm Im by 2. P average equals to Vm Im by root 2, Im by root 2. Basically root 2 is 2, right? P average equals to Vm by root 2 is Vrms. Im by root 2 is Irms. So P average is basically V into I in watts, where V and I are in RMS values. Now we got Vi. Now we can draw the waveform easily. We can draw. So this every waveform will differ. For this waveform, 0 pi 2 pi, this is V. I will have lesser magnitude than voltage. This is I. Positive into positive is positive only. So power will have, because P equals to V into I, right? And again negative is also positive. So this is power, and P V I omega t. So that's it. See, in under 15 minutes you are able to revise it twice, and that also without seeing. I have been honest. I have done it without seeing for the second time. So see you in the next one. If I have helped you in any way to learn this entire thing, for exam point of view mostly, then do check out my other videos. I'm sure I'll be of some help. See you in the next one. Bye bye.